All right, so in this video, we're going to take a look at the difference quotient. Now, difference quotient is one of those pieces that's going to become extremely helpful when you're preparing the way to go into calculus. This is part of what we use to be able to talk about things like derivatives and velocity and the rest of it. That doesn't mean much to you right now, and that's absolutely okay. So what we're going to do is we're going to employ some of our algebraic tools to go about working through difference quotient. This is especially true when we're looking at functions like this, where you've got not only a rational function, you also have a radical. You have a root in this function. Okay, so be on the lookout for the following. You're going to see least common denominator in terms of multiplying by least common denominator come up. You're going to see difference of squares to come up. And those are tools that are going to help you to move through this process smoothly and swiftly. So let's go ahead and dive in. So we're going to set this up as our difference of quotient of f of x plus h minus f of x over h. We're given f of x already. So just to, kind of make sure we're all on the same page tuning it in, I'm going to write down all my players. I've got f of x, it's going to be 1 over square root of x, and f of x plus h just simply means I'm substituting, I'm going to use a pretty h. Ooh. We're going to replace whatever's in our parentheses, whatever's denoting our variable, we're going to replace that in our function. So we're looking at just simply square root of 1 over x plus h. Super fancy. My artistic writing of it, okay? So let's go ahead and set this difference quotient up, shall we? To make things easier on the front end, we're going to hold off on writing the divide by h. We'll see it at the end when I'm writing it, okay? So what I mean is this. F of x of h, f of x plus h is going to be that 1 over the square root of x plus h. And then we're subtracting from it the f of x, which is 1 over the square root of x. Okay, this is going to be our primary focus. It is divided by h, so that part we've not missed. We want to make sure that we're focusing on what's happening in the numerator. Okay, so first thing we're going to do, remember I mentioned looking at least common denominator. So the least common denominator we have, looking at the denominators in our, or the bottom portions of the fractions, the denominators in our numerator for the overall difference quotient, is going to be square root of x and square root of x plus h multiplied. Okay, so that means I'm going to multiply my first term by square root of h, top and bottom, and I'm going to multiply my second term by square root of x plus h, also top and bottom, numerator and denominator. I'm going to move this guy out of the way so I've got a little bit more space. Shrink them down. Thank you kindly. I'll plop that right there. Okay. X plus h. Okay, cool. So once I do that, that's going to cause my numerator of this difference quotient to transform. So now I'm going to be looking at rather, square root of x minus the square root of x plus h over square root of x times square root of x plus h. Get my fancy h on, okay? Still over h, okay? So we did least common denominator. Now we're going to employ difference of squares, okay? So difference of squares is talking about what's happening here in the numerator. Notice that we see the square root of x minus the square root of x plus h. So if I treat this like I would a binomial, so let's say I have, for example, x minus 2, right? If I wanted to not have this huge long term, but I wanted to figure out a way to clear and consolidate as much as possible, I can multiply it by its difference and create a difference of squares like that. Okay? So we're going to do something similar here. However, it's much more powerful when we do this with, our square roots. So let me go ahead and take that off here. So we're going to multiply the numerator and denominator by square root of x plus the square root of x plus h. Right? Same thing here. So whatever we do to the numerator, we do to the denominator. Okay? So once that's done, we've transformed our difference quotient yet again. Because we're looking at these two and it's creating a difference of squares. Difference of squares. That means we're going to end up with the first term squared minus the last term squared. That plays out to our advantage. Because that means we're going to have square root of x squared, which is just x, yay, minus the square root of x plus h squared, which is x plus h. Fantastic. Let me put that fancy h on here. Boom. Okay. And then you have square root of x, square root of x plus h. Oops. Change that color. All over h. Okay. Almost there. Now we have a very nice and clean and very easy on the eyes numerator for this difference quotient. And so what we can do next is we can say, all right, well, I'm going to actually distribute this subtraction. And I'm going to have x. Let me write it over here in green. Here we have x minus x plus h. Oh, that worked out nicely. Because then that means that I can go and those x's can cancel out. So when those x's cancel out, that leaves me with, sorry, I put plus h, my manners. It will be negative. Okay, so x minus h. When we do that, that means that the x's cancel out and we're left with a negative, negative h over square root of x times the square root of x plus h. And this is all divided by h. Now here's where things get really helpful with that divided by h. Because notice that we have an h in the numerator of our numerator, and we have an h in the denominator. In fact, we could be so bold as to rewrite this and say, you know what? Dividing by h is the same as multiplying by 1 over h. Okay. So I've got square root of x and then square root of x plus h. Okay. And when I do that, that means I get to have some things that cancel out. Perfect. Okay. And when we do, that then leaves us with our final answer, which we will put in blue. And that is, we have negative 1 over square root of x times the square root of x plus h. Now, if you wanted to, you could go ahead and combine those two roots together, and you could say it is negative 1. I'll write it over here to the left because I've got that little thing off to the side there. You could say that it's negative 1 over the square root of x squared plus hx. Not necessarily my favorite. I mean, it gets the job done. It is true. We're not lying. That is a true statement, okay? Nevertheless, whichever one you choose, this would be the difference quotient for this particular function. So, hope this process helped. Keep in mind the key tools that we used. One was looking at our least common denominator. 2 was using difference of squares. And the third was using distribution, goodness, that word, using distribution to simplify algebraically our numerator, and away we went. Hope this helps.